Hello everyone, welcome to my channel. My name is Mr.Adebanjo. I want to welcome you to this video. In this video, we are going to be discussing together latitude and longitude as one of the topic in mathematics and further mathematics as a subject. So this topic has been a challenging topic to both learners and teachers. So that's why I made it a point of duty to explain the concept of latitude and longitude for both the teachers and the learners, so that we may understand the dynamics of latitude and longitude as a topic. So what are we going to be doing in this video? We are going to be telling you the description of the Earth as one of the planets, and also we are going to be telling you the difference. We're going to be identifying the lines of latitude and longitude on the Earth's surface, and also we are going to be defining the lines of latitude and longitude as well, and also we are going to be telling the difference between equator and prime meridian also, and also we are going to be differentiating between great and small circles. Then also we are going to be finding the location of points on the Earth's surface. Then also we are going to be talking about the angular distance, which is also called the angular difference between any two locations on the Earth's surface. Also, we have we are going to be talking about the major reason why we are doing latitude and longitude is to find the distance between any two locations on the Earth's surface, whether along great circle or along a parallel latitude, which is also called a small circle. Then we are going to be solving past examination questions, whether was NECO or JAM question that are related to latitude and longitude. So we have a lot to discuss together in this video, and I want to assure you that this video is going to be very helpful to whether the learners and all the teachers that will be teaching this topic in future. So this video, this resource material is going to be very helpful to you. So please get your hands on this video, and please do not rush this video. Take your time to listen and watch the video time with that couple of times, so that you understand the concept of this video. But before we get it started, if you are yet to subscribe to our channel, please click the subscribe button on the channel right away, so that you will help us to improve this channel. And also please, if you don't keep this video to yourself alone, there are students out there who are desperately in need of this resource material to help them understand the dynamics of latitude and longitude. Please share this video. We are appealing to you. Don't keep it to yourself. When you found this video, please share the video on all your social media platforms and the groups that you belong to, so that you help us reach out to as many as possible students or learners who are looking for this resource material. So without wasting much of our time, please let's get started, and let's dive into the topic latitude and longitude. All right, before we talk about lines of latitude and longitude, we need to first of all understand some things about the Earth as one of the planets that we in this solar system. So this picture you are seeing on the screen right now is the pictorial representation of the Earth, which is called the globe. So the Earth that we are in right now is like this, and we need to know some of the features of the Earth. Of course, as you can see, the Earth has a shape. As you can see on the screen right now, you should be able to predict the shape of the Earth. So one of the features of the Earth is that Earth is the third planet from the sun. Like we have other planets in the solar system. So, but the Earth that we are in right now is the third planet from the sun. And we know that it is spherical in shape. It is not round, but spherical in shape. So also, the Earth rotates about its axis, which causes the day and night As you can see, this Earth that we are seeing right now, it rotates, and it rotates about its axis. It rotates about its axis from the west to the east. It rotates. So, and it take it to for it to complete to make a complete rotation, it takes 24 hours, which causes day and night. While some part of the Earth experience the day, that means they are facing the sun currently. So some other part of the Earth will be experiencing darkness. That means they are not facing the sun. So which causes the day and night in the rotation of the Earth. Also, the Earth also revolve around the sun. So as it's rotating, it's also revolve around the sun, and it takes the Earth 365 days to fully revolve around the sun, which causes season. So the revolution of the Earth causes season, while the rotation of the Earth causes day and night. So these are the basic features of the Earth that we need to know as a student or as a learner, since you are not dealing with you are not going to dive a lot more than this into the features of the Earth. So that is not the reason for this video. Is also understand the lines of latitude and longitude. So having done this, let's talk about how we can identify the lines of latitude and longitude on the Earth's surface. Okay, if you can see, this is another pictorial representation of the Earth that we are in right now. So if you can, this is the world globe. We call it globe. Globe, G-L-O-B-E. This is the world globe. That is, it's a representation of the Earth. And if you look at this Earth right now, as you can see that there are some lines on this Earth's surface. As you can see it on the screen, there are some lines. Some are horizontal, as you can see. Some are horizontal line, while some are vertical. So we have vertical lines, we have horizontal line. So horizontal, as a when you have your orange and you cut your orange horizontally, so all this horizontal line will be formed, as you can see on the screen right now. So I'm trying to highlight on the screen. All this horizontal line will be formed, and if you cut your orange also vertically, up, down, you cut it up, down, vertically, then all these vertical lines will be formed as well. So all these lines, whether the horizontal ones or the vertical ones, they are all called imaginary lines. What did I say? They are called imaginary lines. So all the lines on the Earth's surface are called imaginary lines. So why are they called imaginary lines? Because they are not real. They are called imaginary lines because they are not physically real or visible on the ground. As you are in the Earth now, you cannot see all these lines because they are not real. So they are there for a reason. So these are called imaginary lines. As you can see, those lines, like I've explained before, both the horizontal ones and the vertical ones, they are all called imaginary lines. So now let's go back again, please. All they are all called imaginary lines, and those ones that are horizontal, if you have your orange and you cut it horizontally like this, all those horizontal lines will be formed. Those lines are called the lines of latitude. So these lines, all those horizontal lines are called the lines of latitude. Then those vertical ones that come from north, from up down, those ones that come up down, they are called the lines of longitude. So when you cut your orange vertically up down, if you cut it vertically up down, the line that is formed there is called the line of longitude. So that means we can say that the line of latitude are horizontal. They are horizontal, while the lines of longitude, they are vertical lines on the Earth's surface. So you should be able to differentiate between these two lines, although all of them together are called imaginary lines. And I told you because they are not physically real, and having known that all of them are all called imaginary lines, then we should be able to identify which one is line of latitude and which one is line of longitude. So line of latitude are horizontal, those ones that are horizontal, and you can see that they are circular, as you can see. So they are horizontal, and they are called the line of latitude, while the vertically ones, or the vertical ones are called the lines of longitude. So but at now, you should be able to differentiate between the line of latitude or identify the line of latitude and longitude on the Earth's surface. So having been able to do that, let's try to define the line of latitude and the line of longitude. So line of latitude, let's try to define line of latitude. If I have this circle which is representing the Earth now, this circle is representing the Earth that we just saw quite long ago. So, and if I try to include the cardinal points, of course, we know that we have cardinal points on the Earth, and we have the north, we have the south, we have the west, and the east. Excuse me. So this is the Earth. This circle is representing the Earth surface, and these are the four cardinal points. Then, if I cut this Earth horizontally from the west to the north, to the east rather, if I cut this Earth surface, if I cut it from the west to the east horizontally like that, if I cut it like this, I cut it horizontally like as you can see. If I cut it horizontally like this, I believe you know that a line is formed here now. Can you tell me the name of the line? Is it line of latitude or line of longitude? So this is a line of latitude because it is horizontal. So, but one thing I want you to know is that okay, I'm coming to that. So if I should cut another one, if I should cut the Earth in another place horizontally as well, it's going to give us another line of longitude. If I cut it again, I'm going to have another line of latitude. Then if I cut it again, I'm going to have another line of latitude as well. I can see cut it down part here. I have another line of latitude, line of latitude, line of latitude. So all these are called the line of latitude. But there's something I want you to know in their definition. You can identify them by now, but in defining them, a line of latitude is an imaginary line on the Earth's surface that runs from the west to the east. It runs from the west to the east because they are horizontal. It runs from the west to the east, but they are located at the north and the south of the Earth's surface. So a line of latitude are imaginary lines which runs from the west to the east, but are located at the north and the south of the Earth's surface. So this is the definition of a line of latitude. So you can see that they are horizontal because they run from the west to the east. That's why they are horizontal. But where is their location? Some of them are located at the north, some of them are located at the south of the Earth's surface. So one, you should be able to identify the line of latitude. Another thing is that you should be able to define them. They are imaginary lines which are circular in nature. You can see, if you look at this one now, this bold line, this bold half of this circle, this bold line here is talking about the half of the full circle, while this dotted line is talking about the completion of that circle. So they are called imaginary lines because they are not real, like I told you before. But you can see that this runs from the west to the east, and some of them are located at the north, while some of them are located at the south, and they are called line of latitude. Let's try to define line of longitude also. So if I should have a Earth surface and the cardinal point also, now if I cut the Earth surface from the north down, from the north to the south, I cut it from the north to the south, cut from the north to the south, I cut from the north to the south, I cut from the north to the south. Also I can go this way, also I cut it from the north to the south, cut north to south, north to south. So these lines are called line of longitude because they are vertical lines. They run from the north to the south. So all these two lines, as you are seeing, are called line of longitude rather. But where are they located? They are located at the east and at the west of the Earth's surface. So line of longitude are also imaginary lines which run from the north to the south, but some of them are located at the east and the west of the Earth's surface. That is the definition of the line of longitude. So line of longitude, sorry, this is an error. Line of longitude are imaginary lines which run from the north to the south but are located at the west and the east of the Earth's surface. So line of longitude, that is the definition, is that they are the imaginary line that runs from the north to the south. They run from the north to the south but are located at the east and the west of the Earth's surface. So that defines the line of longitude for us also. So if you are to identify the line of latitude and longitude on the Earth's surface, you should be able to identify them or differentiate between them on the Earth's surface, and also you should be able to define them also. So some of these line runs from the west to the east, and they are located at the north and the south of the Earth's surface, while some run from the north to the south, but they are located at the west and the east of the Earth's surface. So should be able to differentiate between one and the other. Now that we understand what a line of latitude and line of longitude are, let's see. Okay, line of longitude are also called meridians. So another name for line of longitude is they are called meridians. So if I should mention meridian, that means you know that I'm referring to line of longitude also. So all line of longitude are also called meridians. So now let's talk about equator and prime meridian. Equator and prime meridian. Now to talk about equator, if I have the Earth's surface like this, represented by this circle, and I have the 4 cardinal points fully represented by the north, west, south, and the east. Now, if I cut the Earth's surface through its center horizontally, if I cut the Earth's surface through its center horizontally, like this, you should know that this line that is formed, I want to ask you, is it a line of latitude or line of longitude? I want you to answer the question by yourself. This line that is formed now, when I cut the Earth horizontally, does it form a line of latitude or line of longitude? The answer is it's a line of latitude. But because we are cutting it through its center, to the center of the Earth's surface, that means it's a line of latitude, but it has its own name, which is equator. So equator is a line of latitude that is formed when the Earth's surface is cut through its center horizontally. So equator is a line of latitude that is formed when the Earth's surface is cut through its center horizontally. So you should know that the equator is also a line of latitude, but because it passes through the center of the Earth's surface horizontally, that means it is called an equator. So an equator is a line of latitude formed when the Earth's surface is cut horizontally through its center. So the first thing I want to know is that there is a line of latitude, fine, but because it passes through the center of this Earth's surface, then it is called an equator. And also, equator has the radius of the Earth because the Earth has a radius. So don't forget that, excuse me, the Earth is spherical. So, and the sphere has a radius. So that means the Earth also has a radius also. So as such, the equator, because it passes through the center of the Earth, it also has the radius of the Earth as well. So you should be able to identify an equator when you see an equator, because it is a line of latitude that is formed when the Earth's surface is cut horizontally through its center. Also, for prime meridian, so if I have a Earth's surface represented by this circle, and I have the 4 cardinal points also. Now, if I cut the Earth's surface or vertically now through its center, another line is formed, which you believe that is a line of longitude, because when you cut the Earth's surface from the north to the south, the line that is formed is a line of longitude. But because it passes through the center of the Earth's surface vertically, then it has its own name also, which is called the prime meridian. Don't forget that I told you that all lines of longitude are also called meridian. That's another name for longitude. But because this line of longitude passes through the center of the Earth, then the name is called prime meridian. So it is called a prime meridian. So prime meridian is a line of longitude formed when the Earth's surface is cut through its center vertically. So by now we should be able to identify a line of latitude, a line of longitude, then we should be able to identify an equator as one of the line of latitude, and we should be able to identify a prime meridian as one of the line of longitude, and we should be able to differentiate between equator and prime meridian. Don't forget that equator is a line of latitude, but it passes through the center of the Earth horizontally, while prime meridian is a line of longitude, but it passes through the center of the Earth vertically. So, and the prime meridian also has the radius of the Earth as well. So that is that on the prime meridian and the equator. Now, having known all these lines and you have been able to differentiate between all these lines that we have been mentioning. Now, let's talk about the angles that latitude carries and the angles that the longitude carries as well. The angles of line of latitude and the angles of the line of longitude. Let's start with the angles of line of latitude. Now, of course, I will tell you very soon the reason why we are doing this. We are studying all this line very soon. Now, the angles that the line of latitude carries is from the 0 degrees to 90 degrees, either to the north or south. Don't forget that the line of latitude are located at the north and the south of the Earth's surface, although they run from the west to the south, but they are located at the north and the south. So that is why the angles of latitude carries north or south. So when you are given an angle in latitude and longitude, you should be able to identify the angle that belongs to latitude, because it's supposed to carry either north or south, and the angle cannot exceed 0 degrees and 90 degrees. Do you understand that? Then also the line of latitude that which carries angle 0 degree is equator. So equator has angle 0 degrees. So why the rest of the line of latitude carry from 1 degrees to 90 degrees. So the line of latitude that has angle 0 degrees is called the equator. Then equator is also called a great circle because it has the radius of the Earth. Then the remaining parallel lines of latitude, which are called small circles, carries the remaining angles 1 degree to 90 degrees, either to the north or to the south. So, for example, I have this Earth surface represented by this circle and the cardinal point. Now, if I draw this from the line that is formed here, you agree with me that this is a line of latitude, but it passes through the center of the Earth. So that means this is an equator. So the equator has the angle of 0 degrees. So this equator, if you anytime you see a line of latitude which carries 0 degrees, you should know that that means they are referencing equator. So any line of latitude that carries 0 degrees is equator automatically. Nobody's going to tell you, but you should know that as a student or a learner. Then also you can draw another line of latitude here, and that will be that means this side is going to the north now. So if I need maybe I will need angle 30 degrees north, so that should be another line of latitude. So I can draw a line of latitude here and give it angle 20 degrees north. I can draw another line of latitude, angle 55 degrees north. I can draw another line of latitude. I can call this one 78 degrees north, and the highest one will be 90 degrees to the north. Then I can draw another line of latitude to the south. That will give, you can label down 30 degrees south. Another line of latitude 60 degrees south. Another line of latitude, I can call this one 80 degrees south, and the highest will be 90 degrees south as well. So the first thing you need to know here is that the line of latitude carries angle from 0 to 90 degrees, either to the north or to the south. And the line of latitude that carries 0 degrees is called the equator. So anytime you are giving a question on latitude and longitude, you should be able to identify which angle belongs to latitude and which angle belongs to longitude. Okay, let's talk about the angles of longitude now. Now, the angles of longitude ranges from 0 degrees to 180 degrees, whether to the west or the east. Don't forget that the line of longitude, they are located either at the east or the west of the Earth's surface, although they run from the north to the south. But some of them are located at the east, some of them are located at the west also. So of the Earth's surface, so their angle ranges from 0 degrees to 180 degrees. So I want to ask you, which line of longitude do you think will carry 0 degrees? What do you think? Which line of longitude do you think will carry 0 degrees? Of course, it's going to be prime meridian. So prime meridian is the line of longitude at the center of the Earth vertically. So it's the one that carries 0 degrees, while the remaining line of longitude will carry from 1 degrees to 180 degrees. So the line of longitude with angle 0 degrees is prime meridian, and the remaining line of longitude carries the remaining angles 1 degree to 180 degrees, either to the west or to the east. So let's see an example. So I have this circle representing the Earth's surface. Then I have the cardinal point. Now we know that line of longitude runs from the north to the south, but they are located at the west and the east. So if I draw this line now, which is a line of longitude, which passes through the center of the Earth, so that will be a prime meridian, and that will carry what angle 0 degrees. So this prime meridian, which is a line of longitude, which is the line, the center of the Earth's surface, when it is cut vertically, so it carries 0 degrees. So then if I should draw another line to the east here now, so that will carry another angle. So, and that should be 60 degrees east. If I should, so if I can label it 60 degrees east, then I can draw another line of longitude, which I can label 100 degrees east. I can draw another line of longitude. I can label that one 157 degrees east, and so on until you get to 180 degrees east. Then also to the west, also I can draw another line of longitude. I can label down 125 degrees west. I can label another line of longitude to be labeled angle 75 degrees west. I can label another line of longitude to be labeled angle 132 degrees west, until we get to 180 degrees west also. So when you see an angle in latitude and longitude, you should be able to identify which angle belongs to latitude and which angle belongs to longitude. And you should be able to know that when it comes to latitude, the latitude ranges from 0 degrees to 90 degrees, and the line of latitude that carries 0 degrees is equator. And you should be able to know that the angle of longitude ranges from 0 degrees to 180 degrees, whether to the west or to the east, because the line of longitude are located at the west and the east of the Earth's surface, and the line of longitude that carries 0 degrees is the prime meridian. All these simple facts, or fact you are meant to know or comprehend as a learner or teacher. Now from there, we need to differentiate between great circles and small circles. All these things we are learning, you are going to be using them very soon in our calculations soon enough. So we need to differentiate between great circle and small circle. Of course, we know that when we look at the Earth's surface, whether the horizontal line, which is called the latitude, they look round and they form a circle, and whether the vertical one, which is called the line of longitude, they also move around and they form a circle as well. So, and some of these lines are categorized as a great circle, and some of them are categorized as small circle. You should be able to differentiate between great circle and small circle on the Earth's surface, because sometimes the question they will ask you to calculate distance between 2 points, either along great circle or along small circle. The question is, if you don't know the meaning of great circle, then there will be problem, and if you don't know the meaning of small circle, there will be problem. Although I've already mentioned some of the great circle in the previous slide, but now we want to know what great circle are. All lines of longitude, which are also called meridian, I told you that before, that longitude, another name for longitude is meridian, and equator are great circle. So what am I saying in essence? Any line of longitude plus equator, because we know that equator is not a line of longitude, it's a line of latitude. So all lines of longitude plus equator are called great circle. So that means from all the line of latitude that we have, it is only equator that is a great circle. But in all the line of longitude, all of them are great circle. And why? Because they all have this radius of the Earth, and the radius of the Earth is used as capital letter R, which is approximately 6,400 kilometers. So all lines of longitude and equator are great circle. And can you tell me then what would now be the line small circle, if you already know the great circle as all line of longitude and equator? So you should be able to tell me the lines of the small circle then. Okay, all lines of latitude, which are called parallel of latitude, except equator are small circle. So all lines of latitude except equator are small circle because they don't have the radius of the head. They have their own radius. They don't have the radius of the head, as you're going to be seeing very, very shortly. So parallel of latitude means they are means small circle. Another name for parallel of latitude, it means small circle. So equator is not a small circle. It is categorized as a great circle. So that means the remaining line of latitude except equator are small circle. Okay, now that we have understood all these simple concepts, and they will help us to know, to understand what we're about to do now, which is talking about how we can locate anything on the Earth's surface, how we can locate any point, houses, countries, streets, airports, seaports, anything namely can be located on the Earth's surface. And how do we do that? Now, before we do that, I want you to have something at the back of your mind. We are getting closer to the calculation part of this topic, and that's the main reason why we are doing this topic in the first place. Now, I want you to know that anything on the Earth's surface falls on a particular line of latitude and a particular line of longitude on the Earth's surface. I come again. Anything you can think of on the Earth's surface, whether human being, houses, countries, states, airports, seaports, anything you can talk about, you can pinpoint their location on the Earth's surface, falls on a particular line of latitude and a particular line of longitude on the Earth's surface. Nigeria as a country that I am in right now, and Lagos State as I am in right now, fall on a particular line of latitude and a particular line of longitude on the Earth's surface, and that is what we call geographical location of anything on the Earth's surface. So if they ask you what's the geographical location of Nigeria, that means they are asking you what line of latitude and what line of longitude does Nigeria fall upon on the Earth's surface. That's what they're asking you in essence. So Lagos State in Nigeria has a line of latitude that is fall upon on the Earth's surface, and it also have a line of longitude that is fall upon on the Earth's surface, and that denotes the geographical location of Nigeria. I hope you understand what I'm trying to say. I am from Ogun State. Ogun State in Nigeria fall in as a geographical location, and what does that mean? It has a line of latitude that it fall upon, and it has a line of longitude that it fall upon. I'm saying it again that every point on everything on the Earth's surface has a particular line of latitude that they fall upon and a particular line of longitude that they fall upon. With that, we can actually locate anything on the Earth's surface. So let's dive into the location of points on the Earth's surface. Imagine now you are to locate this point X on the Earth's surface, and this point S has a geographical location represented in a coordinate form. So the location of this point X, this point X could mean anything. Could mean in a country, could mean a state, could mean anything that you can think of on the Earth's surface. But this point S is located on the 40 degrees north, 100 degrees east. I want you to tell me, out of these two angles, which one represents latitude, which one represents longitude? Which one represents latitude, which one represents longitude? Because one of them represents latitude, one of them represents longitude. Which one? So I want you to answer the question by yourself. Of course, 40 degrees north represents latitude, 100 degrees east represents longitude, and this written is synonymous to coordinates, and we write it as latitude and longitude. So latitude always comes first when you are writing the geographical location. Latitude comes first before you write the longitude. So you don't interchange geographical location. You don't put longitude before you put latitude. And we should know that the angles of latitude carry either north or south. So that's another way you can identify the angles now. Latitude angle of latitude carries either north or south because latitude are located at the north or south of the Earth's surface, while the angles of longitude carries east or west because that's where they are located, and the angle is from 0 degrees to 180 degrees. So you should be able to identify that this is latitude and this one is a longitude. So our aim is to locate this point X, given its geographical location, the Earth surface. You have to locate it on the Earth surface. How do we do that? It's very simple. What do? First of all, draw a circle to represent the Earth surface like this. Then put your cardinal point, the 4 cardinal points, the north, the south, west, and the east. And place in, for the sake of the student, you don't use Bible to draw all these diagram. Please use your pencil so that you can correct the mistake where necessary. So draw the earth surface in the circle to represent the earth surface, then draw the cardinal point. Then you start with the latitude. This point is on the latitude 40 degrees north. So then I'm going to draw a line of latitude, and by now you should know how the line of latitude goes. It's an horizontal line. So I'm going to draw a line of latitude, which is to form a circle there. So I can draw it like this as line of latitude. I can also decide to close it, so give me a full circle. So you can close it like this, or you can just leave it as the ordinary this line that I draw here. So this one is the 40 degree north, because you can see that after this line here, which is representing northwest, down here is south, up here is the north. So you can put your angle, draw it like this. Now don't forget that we are just sketching, we are not measuring the angle using protractor, we are just sketching now. So sketch the line of latitude, which is like this, then you label it 40 degrees north. Then the next thing is to draw the line of longitude, which is 100 degrees east. So that means it's going to go like this, 100 degrees. So line of longitude is from the north to the south, but it is located at the east. So this one is located at the, so I'm going to draw it now longitude like this from the north to this and to the south, and it's located at the east like this. And so I will label it 100 degrees east, as you can see. So this is the line of latitude 40 degrees north, and this is the line of longitude 100 degrees east. So where is point X? Point X is where the is between the intercept is where the line of latitude intercept the line of longitude. And where do they intercept? They intercept right here. So they intersect right here. So that will be the location of the X, of this X on the Earth's surface. So where the line of latitude intersects the line of longitude, that is the location of point X on the Earth's surface, which I believe you understand. So let's do a couple of more. So let's try to locate this point Y on the Earth's surface. So point Y is on the 75 degrees south of latitude and 120 degrees east of longitude. Draw a circle to represent the Earth's surface. Then what will you draw first? You draw the line of latitude, which is 75 degrees east, south, and you should know that it's going to be around here because this is the southern part of the Earth. So a line of latitude, so draw an horizontal circle here like this. So 75 should be close to 90 degrees. Don't forget that the highest degrees of highest angle of latitude is 90 degrees. So 75 should be around here. Then I can close it if I like this. So this is the 75 degrees south of latitude. Then I will label it 75 degrees. Then from there, I will now draw the line of longitude, which is 120 degrees. So I haven't drawn the line of latitude 75 degrees south. The next thing to draw is the line of the longitude. Line of longitude, which is 120 degrees east. So that will be, it will fall at this side. And then if you draw it like this. And 120 degrees, you label it 120 degrees as you want to label it. Then where is point Y? Point Y should be where the line of latitude here intercept the line of longitude. So that means point Y should be around here, as you can see. Then you label it Y. So that means this is the geographical location of point Y on the Earth's surface as well. I hope you understand what you are doing. So this is 120 because the total angle from the angles of longitude ranges from 0 degrees to 180 degrees, like I told you, whether to the west or to the east. So 120 should be very close to 180, which is the last one. So, which I believe you understand how we got this. Also, let's see another example. We have to locate point Z, having the latitude of 50 degrees south and then 97 degrees west of longitude. So draw the circle also to represent the Earth's surface. Draw the cardinal point, then draw the line of latitude first, which is 50 degrees south. Where am I going to draw that? Am I going to draw it here? I'm going to draw it here. So of course I'm going to draw it here. So draw the line of latitude 50 degrees south. then label it 50 degrees south, which is this line of latitude we are having here. Then the line of longitude is 97 degrees west, so which I'm going to draw here, or to the west, of course to the west. So if I draw it, I'll draw it like this. Then that's the line of longitude, and the angle is a 97 degree west. Then where am I going to, where is the location of point Z? So point Z will be around here where they meet. So this point Z here on the Earth surface, and I will label it also. So we can see how to locate that on the Earth surface also. Let's see location of point A on the Earth surface. You can pause this video and try to do location of this point on the Earth surface by yourself. Draw the circle and then locate this point A by yourself. Pause this video, and after you might have done it, then you can now play the video to see whether you are right or wrong. So I believe you have done that by now. So I will draw a circle and the cardinal point, then 77 degrees north of latitude. So that means I'm going to draw a line of latitude around here, because 77 is close to 90 degrees, so 77 will be around here. So I may not decide to close this circle here. It's my choice. So if you like, you can close it to make it a full circle for that latitude. If you like, you can leave it unclosed. Then, which is 77 degrees north of line of latitude. Excuse me. Then I will draw a line of longitude, which is 157 degrees west. So which I'm going to draw around here also. So that's the line of latitude, longitude rather, 157 degrees west. So that means point A should be around here where they meet, where the line of latitude meets with the line of longitude. That is this point here, and that should be point A here. So that is the location of this point A on the Earth's surface also. Now, for example, let's try to locate Lagos State of Nigeria in on the Earth's surface, being on the 6 degrees north of latitude and 3 degrees east of longitude approximately. So now, assuming that this is the geographical location of Lagos State on the Earth's surface, so we want to locate Lagos State on the Earth's surface, you should be able to do this as well. Then I'll draw this circle and the cardinal point. Then this is 6 degrees north of latitude, and we should know that 0 degrees of latitude is the equator, so 6 degrees should be very close to 0 degrees as well, since we are going from 0 to 90 degrees to the north of latitude. So equator is the 0 degrees. Then Lagos State is 60 degrees north. So I will draw a line of latitude around here to represent the 6 degrees north, as you can see. Then I will now draw the line of longitude, which is 3 degrees east. So 3 degrees east also should be very close to the prime meridian, because prime meridian carries 0 degrees on the line of longitude. So 3 degrees east should be very close. So I will draw another line of longitude like this, which is I will label it 3 degrees east of a line of longitude. So can you tell me where Lagos State is right now on the Earth surface? It should be where the line of latitude 6 degrees north intercepts the line of longitude 3 degrees east. So at this point, that will be Lagos, represented by this L. So by now, I want to believe that you can locate any location on the Earth surface given the geographical location of that that point. So once you are given a geographical location of any point on the Earth surface, you should be able to locate the point on the Earth surface. What do I mean by geographical location? I told you that everything on the Earth surface fall on a particular line of latitude and on a particular line of longitude. So which is represented by the angles the lines carries. So in this case, the line of latitude carries 6 degrees, line of longitude carries 3 degrees in this case. So you should be able to locate it on the Earth surface the way you have been doing it. So now, having done that, now the next thing we want to discuss is how do we find the angular difference, which is also called the angular distance between two locations on the Earth surface. We can find angular distance. What do we mean by angular distance? The angle that exists between 2 points. Angular distance means angle between two things or two locations, 2 airports, 2 states, 2 countries, 2 anything you can reference on the Earth surface. How do you find the angle that exists between them? So when you have to find angular distance, it's different from finding distance. Distance is different from angular distance. So you should be able to know what they're asking you to find. Is it angular distance or is it distance? So there are two different things, as you're going to be seeing shortly. So let's see how do we find angular distance, or which is also called angular difference between any two locations on the Earth's surface. Now, let's look at this question now. You have to find the angular difference between point X and point Y. Find the angular difference between point X and point Y. And we are given the geographical location of point X and geographical location of point Y. Now, the first thing I want you to know is that before I can find the angular distance between any 2 points on the Earth's surface, that means those 2 points must have something in common. They must fall on the same particular line, either line of latitude or line of longitude. So before I can find the angular distance between any 2 points on the Earth's surface, those 2 points must have something in common. It's either they have latitude in common or they have longitude in common. In this case, they are on the same latitude, 0 degrees. So they are on the same latitude, 0 degrees, as you can see. And which line of latitude carries 0 degrees? I want to ask you, which line of latitude carries 0 degrees? That is equator. So they are on the same, these 2 points, point S and point Y, they are on the equator. So which is what they have in common? They are on the same line of latitude, which is equator. So then how do we find the angle between them? Pay attention very, very well at this point. I will teach you 2 ways in which you can find the angular distance between 2 points. So one way is to look at the 2 points and you can deduce the angular distance without doing anything. It does to help you when it comes to objective question. And there's another way you can do it from the diagram by drawing the diagram of these 2 points on the same Earth surface. We can still find the angular distance between them. So let's see how you can find the angular distance between them without drawing the diagram at all. Now the first thing to do if you are finding the angular distance between X and Y is to look for what they have in common. What they have in common is that they are on the same equator like this. And that is not what you need to find angular distance. You don't need what they have in common. You need what they have differently, like the word denote difference. What they have differently is what you need to find the angular distance or angular difference. So they are on different different longitude. This one is on 20 degrees, this one is on 45 degrees, and that is what you need to find the angular difference. Then after you look at what they have differently, the angle that they have differently now, then check whether the angles are in the same hemisphere or different hemisphere. What do I mean by hemisphere? Hemisphere is the half of a sphere. Because when you cut the Earth into 2 equal parts, that means the Earth will be divided into 2 different hemispheres. Now, what do I mean by the same hemisphere? This one is in west. This longitude is in west. This one is in the east. So that means they are in different hemispheres. East and west are different hemispheres. But if they are in the same, if this one is in west and this one is also in west, that means they are in the same hemisphere. Or this one is in the east and this one is in the east, that means they are in the same hemisphere as well. So I will come again. Look at the angle that they have it differently, which is in this case they are on different longitude. This one is 20 degrees, this one is 45 degrees. Then check their hemisphere. Are they in the same hemisphere or different hemisphere? In this case, they are in different hemisphere, which is west and the east. Then to get the angular difference, you will add these angles together. That means you'll be having 20 plus 45, which is going to give us 65 degrees. But adding they are in the same hemisphere now. Maybe they are in the same hemisphere, west-west or east-east. That means you are going to subtract the angles to get the angular difference. But in this case now, they are in different hemisphere, west and the east. So that means I'm going to add the angles together to get the angular difference. So that means the angular difference between point X and point Y will be 20 plus 45, which is going to give us 65 degrees. So that's how to get the angular difference without doing anything, by checking the geographical location of the 2 points. Now let's see how to get it using the diagram. So I will draw the diagram like this. The circle to represent the Earth's surface. Locate your cardinal point. Then what do they have in common? They're on the same latitude, which is the equator. I will draw that equator that they have in common. So they're on the equator, which is this line of latitude. So I will label it 0 degrees, which is equator. Then this point S is on this longitude, 20 degrees west. So on this west here, I'm going to draw a line of longitude to represent the longitude of point X. So let's say this is the longitude 20 degrees west. So I will label it 20 degrees west. So that means I should be able to locate point X now. So where will be point X? From what you have been doing so far, point S will be here. So I have point X here. Then also point Y is also on this is also on the equator, on this equator that we have drawn already, but on the longitude 45 degrees east. So I will draw another longitude to represent this point Y. So I will label it 45 degrees east. Then this longitude also meets with this parallel of latitude at this point here. So that means this point will be point what? Y, as you can see. Good. So we can see this diagram now is it explains what you're having here, that there is point X and point Y having different longitude, 45 degrees east, 20 degrees west, but both of them are on the same latitude, which is 0 degrees of equator. So you can see that both of them are on that line of latitude, which is the equator. So this is very explanatory. So we want to find the angular difference between them. After having located the 2 points on the Earth's surface like this, then what do? You need to draw a line from the center of the Earth, because this equator is a great circle. Like I told you, the meaning of a great circle, equator is also a great circle, because that's what they have in common. That's what they are both on. They are on the great circle. They are both, the point X and point Y are on the great circle, which is the equator. So I'm going to draw the radius from the center of the Earth, which is to the from the center to the point X, from the center of the Earth to the point Y as well. Then that means you're having another shape here, which is this part here, which is the part of the circle, which is called an arc, plus this radii. So you can draw that diagram here, this line represented by this line here. Then I have another one which is represent the radius to the Y. I have another one at the middle here, which is this one at the middle. I will draw it also. Then I have an arc from S to Y. So I have an arc like this, as you can see. Then this will be point X here, and there's point Y here. As you can see, our aim is to find the angular distance between point X and Y. So that is this. We are looking for the angle that is between point Y and point X, which is the total angle that is here from here to here. That's what we are looking for. Then how do we find that? You need to get the angle between this middle here, this line at the middle, this radius at the middle will serve as origin of the angle. From the origin here to the point X, the angle there is what? 20 degrees west. So from the origin, which is this line, to the point X, the angle there is 20 degrees. Then also from the origin to the point Y here, the angle there is 45 degrees, which is the longitude also 45 degrees as well. Then our aim is to find the angular distance between X and Y, which is the total angle from here to here. So that's the angular distance from between X and Y, which is total angle from here to here, which is named theta. So how do we find theta? Theta will be 20 plus 45, which is total angle here, because that's the angular distance between X and point Y. And that gives us 20 plus 45, which is going to give us 65 degrees, like we got before using the previous explanation. So these are the two ways in which you can find the angular distance between 2 points on the Earth's surface. You can get it by looking at the 2 points and predicting the angular distance, or by finding it on the using the diagram. Let's see other question that we can solve. Let's see, you have to find the angular distance between point P and point Q. So point P is on 65 degrees south of latitude, 40 degrees east of longitude. Q is 65 degrees south of latitude, 32 degrees west of longitude. So now I want you to look at these 2 points, and I want you to tell me the angular distance. What would be the angular distance between point P and point Q? Now I believe you know the answer now. Alright, what they have in common, they are on the same latitude, which is the 65 degrees south. So we don't need that to find the angular distance. So what we need is what they have, the angle that they have differently, which is this 40 degrees east and the 32 degree west. So they are on different longitude. That's what we need to find the angular difference. and they are also in different hemisphere. This one is in the west, this one is in the east. So that means you add the two angles together to find the angular difference. That means the angular difference will be 72 degrees. 32 plus 40 will give us 72 degrees. Then that is one way. The other way is to draw the diagram quickly. If I draw the circle to represent the Earth's surface, both of them are on the same latitude, which is 65 degrees south. So I will draw that 65 degrees south, or latitude. I will label it like this. Then I want to ask you, this latitude, is it a great circle or a small circle? We have already defined the great circle and small circle. This 65 degrees south of latitude that we have drawn here, is it a great circle or small circle? So it's a small circle, because out of the line of latitude, the only one that is great circle is the equator. So that means this is a small circle. So we have located that. Then let's go back to our point P. So point P is on the longitude 40 degrees east. So you draw the line of longitude 40 degrees east like this. Then label it 40 degrees east. Then where will be point P? Point P will be here, where the line of latitude meets with the line of longitude. So that means point P will be here. So I will label it P. Then for this Q is also on 65 degrees south of latitude, but on longitude 32 degrees west. So that means Q is also on longitude 32 degrees, so which is going to be around here. So I will draw another line of longitude to represent point Q rather. I will label it 32 degrees west. So where will be point Q? Q should be around here also. So I will label that to be point Q. Then, because this is a small circle, this latitude 65 degrees south is a small circle, I'm not going to draw the radius from the center of the Earth, because the small circle, they don't have the radius of the Earth, they have their own radius. So I'm going to draw the radius from the center of the small circle, not the Earth, not from here like I did in the previous one. I'm going to draw it from the center of that small circle. So I'll draw a straight radius from here, another radius like this as well. So this shape now, I will now draw this shape out. So I have something like this you have to draw. So this line, which one? This line represents this one here, as you can see. Then this one represents the one at the middle, and this one represents the one here, and here represent the arc. So where am I going to put my P? My Q will be here, and my P will be here. Then from the origin, which is the center now, the origin line, to the point Q, what is the angle that is there? The angle there is 32 degrees west, which is the longitude. So then from the origin to point P, the angle there is 40 degrees. From the origin to point Q, the angle there is 32 degrees, which is 32. So you are getting the angular distance between Q and P, which is the whole angle from here to here. So which is labeled theta. And then how do we get that? That will be 32 plus 40, and that should give us 72 degrees for angular distance between point P and point Q. I believe you understand that. Let's see more. We have to find the angular difference, which is angular distance between point X and point Y. I want to ask you if you know the answer to that. Look at it and tell me the answer. So I believe you have gotten your answer by now. So point S is on 48 degrees north of latitude, 25 degrees east of longitude. Point Y is on 48 degrees north of latitude, 58 degrees east of longitude. So the angular difference will be 58 minus 25. Why am I subtracting now? Because they are in the same hemisphere, east and east. So 58 minus 25 will give us the angular difference between this X and Y. They are on the same latitude, 48 degrees north, so we don't need that to find the angular difference. We need the angle that they are differently, which is 25 and 58. But they are in the same hemisphere now, which is east. So I'm going to subtract the angle to get the angular difference. So I have 58 minus 25, which is going to give us 33 degrees. Now let's get it using the diagram. I'll also draw the circle to represent the Earth's surface. Include my cardinal points. So the 2 points, they are on the same latitude, 48 degrees north. So I will locate that. So I will locate the latitude of 48 degrees north, which is, I'll draw the line of latitude, then put the angle, which is 48 degrees north. I'm just labeling this now. I'm labeling this angle. Then from there, for their longitudes, This one is in 25 degrees east. This one 58 degrees east. They are in the same hemisphere, east. So which angle do you think I'm going to draw first? Is it 25 or 58, since they are in the same hemisphere? So we know that when it comes to longitude, the first angle at the center is the equator. Sorry, that's the equator. Wrong. Prime meridian rather. For the longitude, prime meridian, which carries 0 degrees. So from 0, I'm going to get to 25 before I get to 58 degrees. So that means I'm going to draw the first longitude I'm going to draw is going to be 25 degrees east. So I will label that 25 degree east. Then that means this point here, where this longitude meets with the latitude, which is this point here, will be point what? Point X. So I will label it point X. Then also I will now draw the longitude of 58 degree east for the Y. I'll draw another line here also, which is going to be labeled 58 degree east. And then that means this point here where this longitude meets with the line of latitude 58 degrees, sorry, 48 degrees. So will be labeled point Y as well. So that is we have been able to locate point X and point Y on the Earth surface. So from there we can see that this latitude that they both are on, they are both on this they are point X and point Y on the same latitude, 48 degrees north. That latitude is a small circle because it is a parallel of latitude. It's not an equator. Neither is it a line of longitude, which are great circle, but this is a line of latitude, which is a small circle. So that means I'm going to draw the radius from the center of the circle, not from the center of the Earth here. So I'm going to draw the radius from here to the line X, and also draw to the point Y. Then I will now bring out this shape. I will draw it. So I have a line here, another line here, another line here. So if I should draw it, I have a line here which is representing this one. I have another one representing this line. I have another one representing this one also. So if I put the arc we have here, so I want to ask you, where am I going to put my X and Y? Where am I going to put my X and Y on the diagram? Where am I going to put my X and Y on this diagram here? I want you to help me to find out. So this point here will serve as our X, and this point will serve as our Y. So then this radius, this here will start at the origin for the angle. So this one will start at the origin, which is represent this part here. Then from here now, our aim is to find the angular distance between point X and point Y, which is the angle from here to here. There's the angular distance. So before we get that, we need to know that from the origin here to point X, the angle there is what's the angle that is there, which is 25 degrees of longitude. So that means from here to here is from the origin to this point, the angle there is the longitude, which is 25 degrees. And also from the origin also to point Y, from the origin to point Y here, the angle there is the longitude also, which is 58 degrees. So from the origin also to point Y, the angle there is 58 degrees also. And our aim is to find the angular distance between point X and point Y, which is from here to here, which is represented by theta. Then how do I get theta? Theta will be equal to 58, the whole angle here, 58 degrees, minus the angle here, which is going to be 25. And if you subtract that, that will give us 33 degrees. That is the angular distance between point X and point Y. Let's find the angular difference between point P and point Q also here. As you can see, P is on 40 degrees north of latitude, 50 degrees east of longitude, and Q is on 30 degrees south of latitude and 50 degrees east of longitude. I want to ask you, can you tell me the angular distance between them? So do you know the angular distance between them? Just look at it critically and check. Okay, I believe you have your answer now. Now they are both on the same longitude, which is 50 degrees east. That's what they have in common. So that is not what you are going to use to find the angular difference. Their differences is the latitude. This one is on 40 degrees north, this one is 30 degrees south. So, and they are in different hemispheres. This one is in the south, this one is in north. So that means the angular difference will be 40 degrees plus 30 degrees, and that should give us 70 degrees. So that's the angular difference between them, 70 degrees. Let's use that diagram to find it. Now, so both point P and point Q, they are on the same longitude, which is 50 degrees east. So draw that first. That's what they have in common. Draw what they have in common first. They're on the same longitude, which is 50 degrees what east. So if I should draw down of longitude 50 degrees, I will label it 50 degrees east. Then point P is on 40 degrees north of latitude. So I will draw that 40 degrees north of latitude to represent point for the point P. So 40 degrees north of latitude. Then that means where the line of latitude intercepts the line of longitude. That is where point P will be. So P will be here. I will label it. Then point Q also is also on that line of longitude 50 degrees east. Then but it's on the latitude 30 degrees south. So I'm going to draw another angle here 30 degrees south to represent the point Q. Then that's for latitude of point Q, 30 degrees south for point Q. Then can you tell me where point Q will be? So where the line of latitude intersects line of longitude, so which is here, and that means point Q will be here. Then that you can see that point Q, point P and point Q, they are both on this line of longitude 50 degree what east. They are both on that line of longitude. That's what they have what they have in common. They're on the same line of longitude 50 degrees east. So I want to ask you, are they on great circle or they are on small circle? This line that they are both on, which is 50 degrees, is it great circle or a small circle? So it's a line of longitude, so that means a great circle, because I told you that all lines of longitude and equator are great circle. So that means that line is a great circle. So I'm going to draw the radius from the center of the earth to the point P to point Q like this as well. So then I'll now redraw the diagram outside. This diagram, I'll draw it outside. So that means I have this line P, I have this line at the middle, I have this line at Q here also. So this one is drawn, draw, then I'll draw the arc also. I want you to locate which one, where am I going to put P, where am I going to put Q? So P will be here, then Q will be here also. Then we have to find the angular distance between point P and point Q, which is the angle between this point Q and to point Q, which is from here to here. Then how do we get that? Let's start. That means this line at the middle here will serve as the origin of the angle. We serve as the origin of the angle. So from the origin to point Q, so to point P rather, what is the angle that is there? That is 40 degrees north. So that means from the origin to this point P, the angle there is 40 degrees. Also from the origin to point Q, what is the angle that is there? The angle that is there is 30 degrees. So 30 degrees. So the angular distance between point P and point Q is the angle from here to here, which is represented by this angle here. Let's label it theta. So theta will be equal to 40 plus 30 degrees, and that will give us 70 degrees. So which is the same thing that we got before. So the angular distance between point P and point Q is 70 degrees. So let's find the angular distance. I want us to understand this more, so that's why we are doing more questions to understand the angular difference. Let's find the angular difference between point A and point B. Point A is on 60 degrees north of latitude, 32 degrees west of longitude. Point B is on the 20 degrees north of latitude, and 32 degrees west of longitude as well. So look at the 2 points. Can you tell me the angular difference between them? Of course, the angular difference between them will be 40 degrees. That will be 60 minus 20 degrees, because they are in the same hemisphere, not. That means I'm going to subtract the angles to get the angular difference. That will be 40 degrees. So let's do it using the diagram as well. So they are both on this longitude 32 degrees west. So I will locate that first. They are both on the same longitude 32 degrees west. So I will locate that first, which is this angle here. Then I will label it 32 degrees west. Then I will the latitude, they are on the same they are on different latitude, 20 degrees and 40 degrees 60 degrees north, and they are both in the same hemisphere, 40 degrees north, 60 degrees north and 20 degrees north. So and which angle am I going to draw first, 20 degrees or 60 degrees? So 20 degrees should come first, because from the middle of the latitude, which is equator, the zero is down is carrying 0 degrees. So from 0 degrees upward, I mean, I'm going to get to 20 before I get to 60 degrees. So that means I'll draw the line of latitude here. So draw another line of latitude here. Will be 20 degrees, representing 20 degrees, which is for the point B. So that means point B will be here, because that's where the latitude intersects the line of longitude. So you have a 20 degrees here. So I have point B here rather. Then I'll need to draw the latitude of point A also, which should be around here also, 60 degrees. Then that means point A will be here also, as you can see. Then both point A and point B, they are on the same line of longitude, which is the 32 degrees west, and the longitude is a gray circle. So that means I'm going to draw the radius from the center of the earth to point B, there to point A as well. Then if I should bring out this diagram, I should be having a line here, because the 20 degrees come before 60 degrees. So that means this line will serve as the origin to 20 to 40 to 60. So I'll draw a straight line here like this, which is represent this one. Then another straight line here, as you can see, for this, another straight one for this one. Then we have an arc. So I will draw an arc there. So point B will be here. So point A will be here also. So point B will be here, point A will be here. Then our aim is to find the angular distance between point A and point B, which is the angle between this point and this point here. Then how do we get that? From the origin to point B, from this origin here, which is this line, to point B, the angle there is what? The angle there is 20 degrees also. Then from the origin also, from the origin here to point A, the angle there is from the origin here to point A, the angle there is 60 degrees, which is this latitude, 60 degrees. Then our aim is to find the angular distance between point A and point B, which is this angle here. So the angular distance is the angle here, which is theta. Then how do we find theta? Theta will be equal to the whole angle here, which is 60, minus the angle here, which is 20. And that will give us 40 degrees for the angular distance between point A and point B. So this is how to find the angular difference between 2 points on the Earth's surface. And the reason why I taught you the two methods is that you may have this kind of question for objective question. You don't need to be drawing diagram to find the angular distance for objective question. You can easily deduce the angular difference from the diagram, from the location given. But if it is theory, you would need to scale the diagram so you can get the angular difference from the diagram if it is theory question. So have you understood how to find the angular difference? Please try this 4 question. Find the angular difference between the pairs of the location given for A, B, C, and D as well, and see what you are going to get. And you can drop your answer in the comment section of this video so as to help you confirm whether you are right or wrong for the angular difference. So the next thing we are going to be discussing is how to find the distance between two locations on the Earth's surface. I said distance, not angular difference. We have already talked about angular distance. Now we want to talk about how we can find distance between any 2 points on the Earth's surface. Now we're going to be finding distance along great circles. We're going to be finding the distance along great circle, distance between any 2 points along great circle. The question is, how do I know that I'm to find the distance along great circle? How do I know, whether I'm told or not, how do I know that I'm supposed to find the distance between any 2 points along the great circle? That has been a major challenge for students when it comes to finding distance between any 2 points. How do I know that I'm to find the distance along the great circle? Of course, we have defined what great circles is before. So when I am given I'm to find the distance between any 2 points, I'm to check at the geographical location of the 2 points given to me. If what they have in common is great circle, that means I'm going to find the distance along the great circle. So if what they have in common is a great circle, that is to say whether they both fall on equator or they both fall on the same longitude, that means I'm going to find the distance along great circle. But if they both fall on the same parallel of latitude, that is any line of latitude that is not an equator, then I'm going to find the distance along small circles. Now let's start with a great circle first. Imagine I have this diagram in the saying that we have a line of latitude which is an equator, and there are two different line of longitude, and that means we have 2 points on the point X and point Y, and both of them are on the equator, as you can see. And equator is a great circle. So if you have to find the distance between point X and point Y, that means you have to do it along that equator, which is also a great circle. So we have to find it along the great circle, which is the equator. So now if I'm to find the distance along the great circle, how do we do that? Of course, now this diagram we are having here, this point X is this, point Y is this, and the radius at the center is the radius here, and what you are having here is the angular distance between the point X and point Y, which is what you have done before, how to find angular distance between 2 points. Then if you have to find the distance between point X and point Y, it's going to be along that equator, because that's what they have in common, along that great circle, which is the arc we are having here. This arc we are having here. So the distance between X and Y is along the great circle, and which is the same thing as the length of this arc. So if I should ask you, do you remember the formula for finding the length of an arc of a circle? So the formula for finding the length of an arc of a circle is theta over 360 times 2 pi r. So the same thing you are going to use to find the distance along the great circle as well. So distance along great circle is theta over 360 times 2 pi r. So where theta is the angular distance or angular difference between the 2 points, and by now you should know how to find the angular difference between any 2 points. Then theta is pi is 20 over 7 or 3.142 or whatsoever is given to you to represent the pi, and r is the radius of this earth. The r is the radius of the earth, which is 6,400 kilometers approximately. So this is the formula you are going to be using to find the distance along great circle. Anytime you are sure that you are finding the distance along great circle, you have to use this formula to find it. All right, let's see that at work. Imagine now you have to find, we are given Y and Z are 2 places on the Earth's surface along the meridian, such that I believe you know the meaning of meridian. They said along the meridian. So such that Y is point Y is on 70 degrees north of latitude, 65 degrees west of longitude, and point Z is 38 degrees south of latitude and 65 degrees west of longitude. So we have to find the distance between point Y and Z now. So we are not finding angular distance. They say you should find distance, calculate the distance. But to find the distance between them. So along this meridian. So what do we mean by meridian? We know that meridian means longitude, and if you have to find the distance between point Y and point Z, how do we find it? Am I going to find it along great circle or along small circle? We are going to find it along that meridian. What is the meridian? Which is 65 degrees west that they have in common. They are both on the same longitude, which is 65 degrees west. So that means we are going to calculate the distance between point Y and Z along the great circle. So before we do that, we need to get the angular distance between them. So we need the angular distance to find the distance between any 2 points. So can you tell me, from what you have done before, can you tell me the angular distance between points Y and Z? So do you know it now? If you know it now, then let's verify it. The angular distance between points Y and Z should be 70 plus 38 degrees. That should give us a 108 degrees as the angular difference between them. So now with you knowing the angular difference, you can just put that formula in that value in place of your theta over 360 times 2 times 20 over 7 times radius of the earth, which is 6,400. If you simplify that with calculator will give you the answer for the distance between Y and Z, if it happens to be an objective question. So you don't need to draw any diagram in that case. But let's see it at work. Let's draw the diagram so as to find the angular difference, then find the distance. Now if this happens to be the Earth's surface and these are the cardinal points, now the point Y and point Z are on the same longitude, which is 65 degrees west. So I will locate that longitude first. So that means I should be having a line of longitude like this here, which is labeled 65 degrees west. Then point Y is on 70 degrees north of latitude, so I will draw a line of latitude like that, 70 degrees west north. Then that means this point here will be in our point what? Our point Y. Then we need to locate point Z as well on the Earth's surface. It's on the same latitude, 65 degrees west. Then the longitude, it's on the same longitude, 65 degrees west, and but different latitude, which is 38 degrees south. So I should have another latitude around here, 38 degrees south. Then that means this place should be point Z. So then both point Y and point Z are on that meridian, which is 65 degree west, and that's a great circle. So that means I'm going to draw the radius from the center of the earth to this point and to this point as well. Then if I should draw the diagram, I should be having something like this. So this diagram we're having here, so this is a line here, another line down, then the middle is the what you're having here. So this is a radius, another radius as well. So they are all radii. Now what can we do? So that means our Y will be around here and our Z will be down here. So the middle line will serve as the origin of the angle if you want to find the angle. So our aim is to find the distance between point Y and Z, which is this arc, and we need to get the angular distance to be able to do that. So from the origin here, which is the center, to the point Z, what is the angle that is there? That will be 38 degrees. So or from the origin to the point is Y, the angle there is 70 degrees. Then to this one also, from the origin to the point Z, the angle there is 38 degrees. And our aim is to find the angular distance between Y and Z, which is the whole angle from here to here, and that gives us theta. So therefore our theta will be 70 plus 38, that gives us 108. Therefore the distance between Y and Z is going to be theta over 36 times 2 pi r. If you substitute, you'll be having 108 divided by 360 times 2 times 20 over 7 times 6,400, which is your radius of the Earth. And if you simplify that with your calculator, that gives us 12,069 kilometers. So that will be the distance between point Y and point Z along that gray circle, which is the meridian, 65 degree west. So that's how to use the formula to solve find distance between 2 points along the gray circle. Let's see something similar to this. We are having that two ships on the equator are on the longitudes 45 degree west and 45 degree respectively. How far are they apart along the equator to two significant figures? You have to take your radius to be this and pi to be this. So that means there are two ships on the equator, and that means you are given their longitude, which is 45 degree west and 45 degree east. So but on in a coordinate form. They didn't give a geographical location of the two ships in a coordinate form, but you can represent it yourself if you want to if you want to know you want to represent the location in a geographical location of the two ships. If you want to write it in a coordinate form, you can rewrite it. So what does that mean? So what will be the latitude of both of them? They said both of them are on the equator. So that means their latitude is 0 degrees. So that means if I rewrite this the coordinate of the two, if I write the geographical location of the two ships, I should be having ship A. Let's assume there is a ship A that will be on the 0 degrees, which is the equator, comma 45 degree east, which is the longitude. Then ship B that also is on the equator, 0 degrees of latitude, comma 45 degree west. So that means this will be the, if I want to interpret this question, this is how I'm going to interpret it in the geographical location. So this is not necessary, but I just wanted to see it, that this word problem can be written like this as well. Then you have to find the distance between them along the equator. So, and the equator is a gray circle. So that means I'm going to find the distance between them along the gray circle. So, but before we do that, we need the angular distance between the point A and point B. So can you tell me the angular distance between them? That should be 90 degrees. That will be 45 plus 45, and that gives us 90 degrees. So that means I don't need the diagram to solve this kind of question. I can just use the formula straight away, since I know the angular distance to be 90 degrees. So I have 90 divided by 360 times 2 pi r. I can substitute and get my answer. But let's see the diagram part, the grammatical part of it now. So I have this diagram with the Earth surface. Then the two the two ships are on the equator, which is 0 degrees. So I will locate my equator for which is this line of latitude 0 degrees. Then after doing that, now point A is on the 45 degree east of longitude. So I'll draw a line of longitude here, 45 degrees, label 45 degrees. Then that means this point will be point A. Then also this one, the longitude of this one is 45 degrees west also. That will be another line of longitude on the west, which is also 45 degrees also for the point B. So that means this place will be point B also. So point A and point B, both of them are on that equator. You can see on that line of equator. So that means an equator is a great circle. So that means I'm going to find the distance between them along that great circle, which is the equator. And that means I'm going to draw the radius from the center of the earth to that point A to point B as well. Then if I draw the diagram outside, I'm going to be having something like this. So this line at the center here will be the origin of the angle. So this will be my point B here, and my point A will be here. So we need the angular distance between point A and point B, which will be the whole angle from here to here. So to get that, I will need the angle from the origin to point A. That should be the line of longitude here, which is to point A, which is 45. So we have 45 from the origin to the point B is 45. From the origin to point A is also 45. So that means the whole angle here, which is the angular distance between them, will be 90 degrees. So therefore, now to find the distance between point A, the two ships, which are named A and B, I have it over 36 times 2 pi r. Then if I substitute correctly, I have it to be d. By simplifying my calculator, I should have 10,057.14 kilometers. You have to change our answer to two significant figure, approximate our answer to two significant figure rather. So that should give us the second significant number here is 0. So if I approximate it, that should give us 10,000 kilometers to two significant figure. So that is another way of solving or finding distance along the great circle. Let's see more questions that could challenge us also. We are having two towns, town A and town B lie on the equator, still on the equator. Town A has 63 degrees east of longitude and B has 126 degrees east of latitude longitude as well. We have to, what is the distance between them along the equator, and how far is town A from the North Pole. So of course I can also represent these two towns. I can represent their geographical location in a coordinate form. This is their longitude. This one is on 63 degrees east, this one is 126 degrees east, but both of them are on the equator, which is a latitude. So that means point A should be 0,63 degrees and B should also be 0 degrees, 126 degrees east, which is their geographical location. If you, according to this statement we are having here, if you understand it, then can you tell me the angular difference between point A and point B? Of course, it's going to be 126 degrees minus 63 degrees, because they are in the same hemispheres. They are in the same hemisphere, which is east and east. So you are going to subtract the angle to get the angular difference. So that will be 126 divided by 126 minus 63. That will give us 63 also. So let's draw the diagram. So they are both on the equator. So you draw the equator first, so which is 0 degrees. Then their differences is the longitude. They are on the same different longitude, but in the same hemisphere, which is east and east. So I'm going to draw angle 63 degrees first. So if the first longitude will be 63 degrees, which is for point A. Then so that means I'm going to be having A here. So I'm going to having point A here. Then also for the second one, the longitude is 126 degrees. So I'm going to draw another longitude at the east also, label 126 degrees east. Then this point will be point B, as you can see. Then both of them are on that gray circle, which is the equator. So I'm going to draw a line from the center of the earth to the point A and then to point B as well. Then if I bring out the diagram, so I'm going to be having this line from the origin, point A and point B. So I'll be having something like this with the arc. So we have a point A here and we have point B here, and we have to find the angular distance between them, which is going to be angle from here to here between here and B. Then before we can do that, we need to get the angle from here to here, which is from the origin to point A. What is the angle that is there? That should be that longitude, which is 63 degrees. And also from the origin to point B, what is the angle that is there? We have 126 degrees. And our aim is to find the angular distance between point A and point B, which is from there to there. That will be theta. So therefore, theta will be 126 minus 63. And that should give us 63 degrees. Therefore, now to find the distance between town A and town B, that will be theta over 360 times 2 pi r, since we are doing it along the great circle, which is this equator. If you substitute, you have a 63 divided by 360 times 2 times 20 over 7 times 64 times 6,400. If you multiply out, we have 7,040 kilometers for the distance between town A and town B. Then for question number B, how far is town A from the North Pole? How far is this town A from the North Pole? So the distance of town A from the North Pole is along that longitude that join A to the North Pole, which is this longitude here. So that's how you're going to find the distance of A from the North Pole along this longitude. And can you tell me the angular distance between point A and the North? The angular distance between them is 90 degrees, because the equator, the angle of equator is 0 degrees, and from 0 to the North Pole is 90 degrees that we have there. So that means the angular distance of point A to the North Pole is 90 degrees. We are going to find the distance along the longitude here, which is a great circle. So that means theta is equal to 90 degrees along angular distance from the North Pole. So that means I'll be having A from the North Pole to be equal to theta over 360 times 2 pi r as well, because this is also an arc, and we are calculating the distance along the great circle also. So we are going to use this formula also. So that means we'll be substituting your theta to be 90 over 360 times 2 times 20 over 7 times 6,400, which is going to give us 10,057.14 kilometers. So, and the same question we are having here, they can also ask to find the distance of A from the South Pole, which is the same thing you are going to do, because the angle of the A from the South Pole is also 90 degrees. The same thing with the distance of B from the North Pole. The angle is also 90 degrees. The same thing of the point B from the South Pole as well. The angle is also 90 degrees as well. So that means point A have the same distance from the North Pole and from the South Pole. Also, point B has the same distance from the North Pole and from the South Pole as well, which is 10,057.14 kilometers. So you are still trying to demonstrate how to find the angle, find the distance along great circle. All right, let's see the just concluded WAEC 2025. There was a question given to them on latitude and longitude, and the question is what you are seeing on the screen right now. You are told that the point X and the point Y lie on the Earth's surface. You have to illustrate the information in the diagram, then find the distance between X and Y along the meridian. Excuse me, please. So this is a WAEC past question for WASSE 2025. They just concluded the WASSE 2025. Now you have to draw the diagram first. So I'll draw a circle to represent the Earth's surface. Then I'll draw my cardinal point. So then from there, both point X and point Y, they are on the same longitude, which is 60 degrees east. They are on the same longitude, 60 degrees east. So what do? Locate that longitude first. So if you locate the longitude, so 60 degrees east, that will be 60 degrees here. So you locate that longitude, you draw the longitude, and that will give us 60 degrees east. Then point X and point Y, they are on the different on different latitude, 70 degrees south and 7 degrees south, but in the same hemisphere, which is south. So that means if you want to find the angular distance between them, what can we do? That means you're going to subtract these angles, and that should give us 70 minus 7. That will give us 63 degrees for the angular difference. But let's see that in the diagram as you have to draw. So to draw the latitude of 70 degrees and the 7 degrees, which one am I going to draw first? Is it 70 or 7? Don't forget that for the latitude will begin with angle 0, which is for equator. So that means I'm going to get to 7 before I get to 70. So now I'm going to draw angle 7 first, which is this line of latitude, ably represented by this diagram. So I will label it 7 degrees. So that means this point here will be point Y. Then I will now draw another latitude, which is represented by 70 degrees south. For the that will represent at this point our point what? Point X here. So you can see that both point X and point Y, they are on this longitude 60 degrees east. So that means they are both on the great circle, because all lines of longitude are also great circle. So that means I'm going to find the distance between them along that great circle. So because it's a great circle, I'm going to draw the radius from the center of the earth to that point Y up to point X also. Then if I draw the diagram, this diagram, so I'm going to have something like this. So with the arc, this arc here, I have the arc like that. Then this line here, where am I going to put my Y? Because I'm starting the between the angle 7 degrees and 70 degrees. This one is closer to 0 to the origin. So that means this line will be the origin. So this will be our origin, and this will be our X. Sorry, this will be our Y rather, and this will be our X. So we have our X here, we have our Y here, and this line will be our origin, because 7 is closer to 0, angle 0 here, than 70. So that means that this line we are having here will be our origin, start for our origin, not this one here. Because if you use this one here, you're telling you you're going to get to 70 before you get to 7, which is wrong in that case. So our aim is to find the angular distance between point X and point Y, which is the angle that is here. And how do we get that? So we need from the origin, which is this line that represents the east, from the origin to point Y, the angle that is here is 7 degrees. So okay, that you are looking for theta, which is the angular distance. So from the origin to point Y, the angle there is 70 degrees. And also from the origin here to point X, the total angle here is 70 degrees. So to now find theta will be 70 minus 7, and that will give us 63 degrees. Then from there, to now find the distance along the meridian, the distance along this meridian, which is the great circle, that will be distance along great circle, that will be theta over 360 times 2 pi r. And you have 63 over 360 times 2 times 22 over 7 times 6,400, and that will give us 7,040 kilometers rather, as the distance between point X and point Y. Okay, there could also be questions that will be given to you that are not direct question. They are not direct question. So you may be given the okay, don't worry, let's try to read the question. Town M and Q are on the equator and are on longitude 70 degrees east and 168 degrees west respectively. You have to find the distance between them. So I can represent point M and point Q as their geographical location, since they are both on the equator. So that means their latitude is 0 degrees and 0 degrees. Their longitude is 70 degrees and 168 degrees west. So if I'm to represent that, that means this will be represent point M and point Q. So if you have to draw the diagram for this, then both of them are on the same what's it called, on the equator. So that means I'm going to draw my equator, put my 0 degrees. Then this one is okay. If I should ask you what will be the angular distance between point M and point Q, so that should be 70 plus 168, because they are in different hemispheres. We are going to add the angles together, which should be 238, I think. Sorry, 228. No, 238 rather. I'm correct. So let's complete the diagram. So point M is on 70 degrees east of longitude. So I'll draw a longitude here, which is 70 degrees east. That means this point will be our point M. Then point Q is on the 168 degrees west of longitude also. So I'm going to draw a longitude here, 168 degrees west. Then that means this point will be our point Q. Then both of them are on this equator, which is a great circle. So I'm going to draw my radius from the center of the earth to that point and to this point. So if I bring out the diagram, I have this something like this. So this is point Q, this is point M. So that means our Q should be here, our M should be here. That means this line at the middle should be the origin. So if I have to find the angular difference between them, that should be the whole angle from here to here. Then before we get that, from the origin to point Q, the angle there is 168. So we have 168 from the origin also, which is the middle to the point M here. The angle here is 70. So you have 70. Then our aim is to find the angular distance between M and Q and M. That will give us theta, which is the addition of the two angles. That will give us 238 degrees. So we have to find the distance between them, between point M and point Q, along great circle, along small circle. It's going to be along the great circle because we are finding along that equator, which is a great circle. So which I'm going to use distance between M and Q is equal to theta over 3 times 2 pi r. If I substitute, I have 238 over 360 times 2 times 22 over 7 times 6,400. That should give us 26,595.56 kilometers. So that is for part A. Then for part B of that question, that one is an indirect question. And let's see how we are going to do that or get that. They said that if town R is also on equator, that means there's another town, which is a third town now. It's also on the equator. Now, where is it located? It's also on this equator and is 2,500 kilometers. That means the distance east of town M. So that means there's another town R east of town M. So this is the east of this M here, around somewhere here. So that means there's going to be around another point here. Let's call it which is R. Let's make let's say assuming it is here, but you can told that that R is on that equator, but east of this town M. So that means I can put it here. Then what do you think is missing? That means this town R here is going to have its own longitude, and that is what you have to find. What is the longitude of R? That means the town R is also on the latitude, which is the equator. So that means his latitude is 0 degrees, but he's going to have a different different longitude, which is what I just marked now. It's going to have there's another longitude that will pass through that point R. So that's what they want to find. They also to what is the longitude of R? That's what we don't know. Are we there? Good. Then if you are there, but we are given the distance between point M and R. We are told that town R is also an equator, is on the equator, and is 2,500 kilometers east to town M. So that means the distance between town M and town R is 2,500 kilometers. So we can use that to find the longitude of R that we want us to find. So since R is also on the equator, so that means I can draw the radius from the center also to that point R. Then I can now bring out this diagram between M and R. So that will be this line, then this radius and this radius. So I'll be having something like this and draw the arc. So this will be our point M here, our point R will be here, and this line will be our origin. So because this longitude is more than this longitude here, so this will be our origin to the small longitude, and this one is bigger than the other one here. So that means I'll be having my M here, our R will be here also. Then from the origin to point M here, what is the angle that is there? That should be that longitude, which is 70 degrees. Okay, we know the distance between point M and R, which is 2,500 kilometers. Then the origin from the origin here, which is this line here, this radius, to the point M, the angle there is 70 degrees, which is that longitude we are having here. So our aim is to find the longitude of R, which is the angle from the origin to point R here, which is from here to here. That's what we are looking for. We are looking for the longitude of R, which is the angle from the origin to the point R here, which is from here to here, which is represented by this. So we don't know that. That's what we are looking for. That's why I put question mark there. So then we can find the angular distance between point M and R, which is at this angle here, which is theta. If you can find this angle theta, which is the angular distance between point M and R, then we'll be able to know the whole angle that is here, which is representing the longitude of R. Do you understand that? So if I can find the angular distance between point M and R, because we are given this the distance between them, which is 2,500 kilometers, you can use that to find the angular distance between them. Having known that, we can now find the longitude of R, which is the angle from this origin to this point here. So how do we find that? Let's now find the angular distance using the distance here. So we are going to find the distance between M and R on that equator also, which is also a great circle. So I'm going to find the distance MR equals to theta over 360 times 2 pi r. Our MR, distance between M and R, is 2,500. So that will replace this. You'll be at 2,500 equals to theta over 360 times 2 times 22 over 7 times 2,400. Then if you simplify this, if you simplify 2 times 22 times 6,400 rather, that will give us a 281,600 multiplied by theta over 360 times 7 give us a 2,520. You can cross multiply from there. If you cross multiply, this will multiply this equals to this. You can now divide both sides by 281,600. That will give us whatever you are having here. Press your calculator. Theta will be 22 degrees. So that means the angular distance between point M and R, which is this theta, is 22 degrees. Therefore, now that we know this angle to be 22 degrees, we can now find the whole angle here, which is representing the longitude of R. So therefore, the longitude of R will be 70 plus theta, which is 22. And that will give us 92 degree. And the longitude is in the east. That will give us 92 degree east as the longitude of R. So this is a wide pass question also. And it's very, I believe it's, you understand what you have done there. So that is how to find the distance along the great circle. And we are still going to be doing more of that, as you are going to be seeing more wide pass questions to deal with. Now that we have talked about the distance along great circle and how to solve it, let's see how we can find distance along parallel of latitude, which is also called the small circles. So imagine I have a great circle. I have this diagram rather, and I have which is what's it called, the equator, and I have a small circle here, which is not an equator, this small circle. Then if that small circle have their own radius, the radius of the small circle is derived from the radius of the big circle. That is the difference between them. So the great circle here, they have the radius of the head, which is the big capital letter R, but the small circle have their own radius, which is a small letter R, represented by small letter R. So that small letter R need to be converted to capital letter R before we can use them. So what do? If I draw this radius of the small circle is labeled small letter R. So if I draw a line from this center of the head to this point here, that will also represent the radius of the head, which is capital letter R. Then if I draw an angle here, call it beta, that means the angle here will also be beta because they are alternate angles. So we are having another shape here, which is a right angle triangle. So this is R, this is capital letter R, and this angle is a beta. So we can find the relationship between this small letter R, this capital letter R, and this theta, this beta rather, using trigonometric ratio. So that should be adjacent of this angle over hypotenuse, which is cos. So we'll be having cos theta. So cos beta equals to small letter R over big R. And if you cross multiply, you'll be having the small letter R, which is the radius of the parallel of latitude, is equal to big R cos beta, where this beta is the parallel of latitude that you are, that small latitude, the parallel of latitude that you are on. That's it, that small circle, which that will represent this this angle here. Your big R is the radius of the earth, and the small r we are finding is the radius of the small circle. So anytime you have a radius of a small circle, is to be represented by big R cos beta. So where r is the radius of the earth and the beta is the parallel of latitude that you are on. So therefore, to now find the distance along parallel of latitude, which is also called small circle. I need the distance to be equal to theta over 360 times 2 pi small r. So you should know the difference between this formula and the that of a great circle. So in great circle is theta over 360 times 2 pi big R. But in small circle, this along small circle, you have theta over 360 times 2 pi small r. But what is your small r? Your small r, which is representing the radius of the small circle, is equal to big R cos beta. So that will represent this small r here. That the formula becomes theta over 360 times 2 pi big R cos beta. So with this formula now, we can use it to find distance along small circle. With this formula, you can find the distance along the small circle. So I want you to pause and try to compare this formula and see the difference between this and the gray circle. So having understood this, now let's now use this to solve some problems. Okay, where theta is an angular distance or angular difference like you know before. So let's find the distance between point A and point B. So we are not told whether along gray circle or along small circle, but you need to know whether you are finding along gray circle or along small circle. So what do you think? Is it along gray circle you are going to find the distance between point A and point B, or along small circle? It's going to be along small circle because they are on the same latitude, 60 degrees north. And that latitude is not a gray circle, it's a small circle. Because from the latitude, only equator is the gray circle from all the latitude. So since this angle is not for equator, that means the angle is for small circle. So and both of them, the distance between them will be found along that small circle because that's what they have in common. So then if you know that we will need the angular distance to find the distance between them also. So how do you find the angular distance between them? What will be the angular distance between point A and point B? That should be 40 plus 70 degrees. That will give us 110 degrees because they are in the different hemisphere, west and the east. So let's try to draw the diagram for this as well. So if I locate what they have in common, which is the on the same latitude 60 degrees north. If I locate that, I have 60 degrees north. So point A is on 40 degrees west. So if I draw that, then that means this place will be point A. Then point B is on 70 degrees east. I'll draw that also. So that means this point will be point B. Then we can see that both of them are on this small circle, which is that latitude 60 degrees north. So I'm going to find the distance between them along that small circle, along that latitude, which is a small circle. So because there is a small circle, I'm going to draw the radius from the center of this circle, not from the center of the earth, because this is a small circle. So I'll draw the radius from here to here and to here. So the diagram goes like this as you are seeing it here. So this will be point A and this will be point B. So the angle, that means the middle line will sign up as the origin of the angle. From the origin to point A, the angle there is 40 degrees north. Sorry, 40 degrees rather. That'll give us that. And from the origin to point B, the angle there is what this angle here, that will be 70 degrees. So that means the angular distance between point A and point B, that will be from here to here. That will be theta. So that will give us a theta to be 40 plus 70. That will give us 110 degrees. Now that we know the angular distance between point A and point B, so we want to find the distance between them now. So that means you're going to find the distance along the small circle, which is that latitude, which is a small circle. So distance between point A and B will be theta over 360 times 2 pi r cos beta, which is the formula for finding distance along small circle. Our theta is 110. If you substitute that, we have 110 over 360 times 2 times 22 over 7 times 6400 cos beta, which is the parallel of latitude that they are on, which is 60 degrees. So that means we'll be having something like this. Then if you press your calculator will give you the answer to be 6146.03 kilometers to 2 decimal places. So this will be the distance between town A and town B, or point A and point B, along that parallel of latitude, which is a small circle. We are told that there is a town P and there's 2 points P and Q on latitude 40 degrees south and longitude 15 degrees west and 45 degrees west respectively. We have to find the distance between point P and Q along the parallel of latitude correct to the nearest 100 kilometers. So P and Q are on this latitude 40 degrees south. That's what they have in common. And their differences is the longitude, 15-degree west and 45-degree west. So if you represent that in a geographical location, if you in a coordinate form, that means for the point P, you should be having 40 degrees west, south rather, for the latitude, and its longitude is 15-degree west. Point Q as well is still, that one is also on the same latitude, 40 degrees south and 45-degree west also. Then if I ask you to tell me the angular distance between them, because we will need that to find the distance, so that should be 45 degrees minus 15 degrees, because they are in the same hemisphere, west and west. So from there, that means the angular difference will be 30 degrees, and you can use that, put that into the formula. That will give you the distance between them if this happens to be an objective question. So, and don't forget that you are calculating the distance between them along this latitude that they have in common, which is 40 degrees south, which is a small circle, not a great circle. So if you draw the diagram, then what they have in common is 40 degrees south. You locate it first, which is this 40 degrees south. Then their differences is the longitude, but they are in the same hemisphere, west and west. So I will locate 15 before I locate 45. So the longitude of 15 degrees, that will be for this one, west. So I will label it to be west. So that means this point will be point P. Then also for the longitude of point Q, that's 45 degrees as well. So 45 degrees. Then that means this place will be point Q also. Then this is a small circle. They are both on that small circle. Then I'll draw the radius from the center of this circle, not from the center of the not from the center of the head. So, and if I bring out the diagram here, I'll have something like this. So that means this longitude here is 15, this is 45. So from that means this line will be the origin, because I'll get to 15 before I get to 45. So that means this line will be origin. So that means this will be origin. This will be P, and this will be what, Q here. Then the angular distance between them is between P and Q, which is from here to here. Then that's the angular distance. Then how do we find it? From the origin to point P, the angle there is 15 degrees. So that means from the origin to this point here, the angle there is 15 degrees. Likewise, from the origin also to point Q, from the origin to point Q, the angle there is 45 degree also. So then our aim is to find from here to here. If the whole angle is 45, that means you need to remove 15 from 45 to get theta. So theta will be 45 minus theta will give us 30 degrees for the angular difference between them. Therefore, to now find the distance between them along this parallel of latitude, 40 degrees south, so that means you need to find it along the small circle. So distance PQ will be theta over 360 times 2 pi r cos theta cos beta rather. So your theta is 30 degrees over 360 times 2 times 22 over 7 times 6400 cos the beta, which is the latitude that they are both on, which is that 40 degrees. So if you use your calculator on this, that gives us a 2568.0607 kilometers. We have to approximate our answer to 100 kilometers, which should be our emphasis on 5 here, because that will be this is 10 unit times 100. So emphasis on 5 here. Then the number after it, before it is up to 5, you round it up to 1 and add it 5 to 5. So that gives us 2,600 kilometer to the nearest 100 kilometer. That's approximation, and that should be 1 mark. So that's the solution to that question, and I believe you understand this. Okay, let's see another question also on this. So we're having that this is a wire pass question also, and this is a complete question, and we are told that there is a point K on 60 degrees north and 50 degrees west. It's a point on the Earth's surface. So L is another point due east of K. So before we do this, let's first of all locate this point K on the Earth's surface, because this question is an indirect question. So let's try to draw the diagram. So let's assume that this is the Earth's surface. We have done the cardinal point. So let's locate point K first on the Earth's surface. K is on 60 degrees north of latitude. So I'll draw that latitude 60 degrees north. Its longitude is 50 degrees west. So I'll draw a longitude here, 50 degrees west. That means this point will be our point what? Point K. So you have been able to locate point K on the Earth's surface. And we are told that this point K is a point on the Earth's surface, which is what you have done. L is another point due east of K. There's another point. There's another point L. It is due east of K. So you should know that that means that this point L, which is due east of this K, that means this east is around somewhere here now. East of K should be around here. That means L will also be on the same latitude, which is going to be on this same latitude here. So that means I can locate my L around here now. So label it L. Then that means L will have its own longitude. L is on the same latitude as K because they are told that this L is due east of K. So that means L will have its own longitude. And that's what they want us to find. They want us to find the longitude of L. Are we there? Good. So, and we have been given the distance between K and L, which is 3,520 kilometers. We're going to use that very soon. Then if you continue that question, we are told that and there is a third point N. There's another point which is the third point N, and it's due south of K. So there's another point N around somewhere N, and we're told that it is due south of this K. So that means there should be a line that will join K to N, and that should be this line of longitude that's coming down here, because we are told that the N is in south, so south of K. So that means something will join them together also, which should be this line of longitude. So that means N should be around somewhere here. Okay, I was trying to join this one to make it so N should be around somewhere here. Okay, I didn't do that first. All right. Okay, I mean I solved that question before I went to do the third one. Okay, let's see. So let's go back. So there's L is another point due K, which is what you have drawn here also. So because this is a small circle, the radius will be from the center of that circle to this point, and that will give us this diagram we are having here. So our K will be here and our L will be here. So this center will be the origin. So what can we do? We are given the distance between point K and L, which is 3,520. So from the origin to point K, with the angle there is the longitude, which is 50 degrees, and the angle from here, from the origin to the point L, which is the longitude, that's what we are looking for. We are looking for that longitude, we don't know. So, but we can find the angular distance between K and L, which is the whole angle from here to here. We can find out which is theta, because we are given the distance between K and L, which is the 3,520. So if you can find theta, then to now get this longitude, which is this angle here, all we need to do is to remove 50 degrees from this angle theta, which is the angular distance between K and L. So the question is, am I finding the distance between K and L along great circle or along small circle? That's the question we need to ask ourselves. So the distance is along that parallel of latitude 60 degrees north, which is a small circle. So I'm going to find the distance along small circle. So distance KL will be theta by 360 times 2 pi r cos beta, which is the formula for finding the distance along small circle. Then we are given distance KL, which is 3,520 times equals to theta over 360, because I was looking for our theta, which is the angular distance, times 2 times 22 over 7 times 400 cos beta, which is the latitude that they are both on, which is 60 degrees. If you simplify this further, I can multiply the numerator divided by denominator here. So that means I should be having 3,520 equals to 2 times 22 times 6,400 cos 60 will give us 140,800 theta over 360 times 7 will give us 2,520. From there, if you cross multiply, you will be having this, then divide both sides by 140,800. So you'll be having theta to be 63 degrees. So theta is 63 degrees. So that means the whole angle here, the angular distance between K and L is 63 degrees. Therefore, now to find our angle here, which is the longitude of L. So that should be 50 degrees minus theta. So longitude of L will be 63 degrees minus 50 degrees, because the angle here plus the angle here will give us the old angle here, which is the theta. So that will give us 13 degrees, and our L is in the east, which is the longitude is in the east. So that will give us 13 degree east as the longitude of L. So the longitude of L is going to be 13 degree east. So as I was saying before, we are told that there is a third point N, which is due south of K. So there's another point which is N, and it is due south of this K. So that means this line, which is this longitude 50 degree west, should be the line to join them together. So that means there will go to be another point here, which is labeled N. Then that means N will have its own latitude, because it already have a longitude, because it is in the south of the K. So that means they are on the same longitude. So N is going to have its own latitude. So that's what they ask you to find the latitude of N. So we are going to find the latitude of this N. How do we do that? Then we have been given the distance between K and N. From here to here, we have been given as 10,951 kilometers. So are we going to find the distance between K and N along great circle or small circle? It's going to be along this longitude, which is the great circle. So, and we know that great circle has the radius of the Earth. So I'm going to draw the radius from the center of the Earth to this point here and to this point here. So if I bring out the diagram, I should be having something like this also. So this line at the middle and this radius here. So that means my K should be here, while this line at the middle is the origin of the angle, and this line here should be my N. So, and what do we have? We are given the distance between K and N, which is 10,951 kilometers. Then from the origin to point K, what is the angle that is there? That should be 60 degrees. From the origin to point K, the angle there is 60 degrees, which is that latitude. Then from the origin to point N, what is the angle that is there? That's what we are looking for. So we are looking for the latitude of N. But if you can find the angular distance, which is the whole angular distance between K and N, which is the whole angle that is here, if you can find it, which is theta, then we'll be able to know the latitude of N, which is the angle that is here. So what do? We have to find the distance between K and N along that longitude that they have in common, that they are both on, which is a great circle. So I'm going to calculate the distance between K and N along the great circle. That means we need the theta over 3 times 2 pi r in that case. So distance Kn is 10,951 kilometer, equals to theta over 360 times 2 times 20 over 7 times 6,400. If you simplify this further, multiply the numerator divided by the denominator, will be having this cross multiply. You have this times theta equals to this times this, divide both sides by 281,600. You will be having theta to be 98 degrees. So the theta here is 98 degrees. So if theta is 98 degrees, how do we find this angle that is here, which is the latitude of N? So that should be 98 degrees minus 60 degrees. So that will give us 98 degrees minus 60 degrees, and that should give us 38 degrees. And that latitude is in the south. So that means we are 38 degrees south as the latitude of N. So that means this latitude will be 38 degrees south. So that question was a pass question, which comprises of distance along great circle and distance along small circle. So these are the questions that we are going to be seeing shortly. There could be a question given to you that comprises of both great circle and small circle. So now look at this question. Now this is a complete question, a complete wire pass question. And in this case, we are having 3 points, not 2 points. Let's say 2 towns, K and Q, are on the parallel of latitudes 46 degrees north. So longitude of town K is 130 degrees west, and that of Q is 103 degrees west. So, and a town P is also on the 46 degrees north of latitude, and its own longitude is 23 degrees. Calculate the length of the parallel latitude 46 degrees north to the nearest 100 kilometers and the rest. Now let's try to see the picture form of this question. Of course, if you want to do, you can first of all represent the geographical location of each of the point. You can write it in a coordinate form, but it is not necessary. So we are having town K and Q, and they are both on this latitude. That means that's what they have in common, which is 46 degrees north. And I'll draw that for 6 degrees north. So, and their longitude, they are on different longitude, but in the same hemisphere. So 136 degree west, 100 degree west. So different longitude, but the same hemisphere. So K is on 130 degree west, and Q is on 103 degree west. So which one am I going to do first? I'll do 103 degree west first. So I will locate that of longitude. So that means this point should be point Q. So I will label this longitude. That will be 103, not 130. Sorry, this is an error. 103 degree west. So that means this point should be point Q. Okay, let's see what I did now. Okay, no problem. There's no problem about that. So I'm supposed to do this one first, which is 103, but I did 130 first. So I want to go and put this one at the back here. That will be an error, but it's still correct. So this is point K because its own longitude is 130 degree west. Then for point Q, its own longitude is 103 degree west, which should come before 130 degrees. So this is still perfect. So that means this point will be point Q. Then we are going to find the distance between K and Q along that parallel of latitude 46 degrees north. And this latitude you are seeing here is a small circle. So that means I'm going to draw the radius from the center here to the point K and to point Q here. Then what are we have to find first? Okay, I located the other one. Okay, so we are also told that there's another point P, which is also on 46 degrees north, 46 degrees north of latitude. That means still on this latitude, and its own longitude is 23 degrees east. So that means its own longitude is going to be on the east, which is 23 degrees east. Then that means this point will be point P. So that is also on the small circle. That means I'm going to draw the radius also from here to here as well. So this is the diagram that represent this whole information. The first question that we have to calculate is you have to calculate the length of the parallel of the latitude for 6 degrees north. What does that mean? Calculate the length of that parallel of latitude for 6 degrees north. They want to know the length of this parallel of latitude. The length of it, that's the length of that circle. That is what they want you to find the length of that circle, which is the parallel of latitude for 6 degrees north. How long is it? Or yes, how long is it? So they want you to measure the circle. How long is it? And if you are finding the length of a circle, what are you trying to find? You are trying to measure the circumference of the circle. So that means what you are finding here is the circumference of that latitude for 6 degrees. That's what they want you to find for the first question. The length of the parallel of latitude for 6 degrees north, which is the length of this parallel of latitude for 6 degrees north. How long is it? So which you are going to use the formula for finding circumference of a circle. So the length of the parallel of latitude is the same as the circumference of that circle. So what do you use to find the circumference of a circle? That is 2 pi r. 2 pi r. And then in this case, you're going to be using 2 small letter r because it's a small circle. So small letter r. And we know that our small letter r is equal to big R cos beta. So our small r is equal to big R cos beta. So that means the formula for finding the circumference of a circle becomes 2 pi big R cos beta. So in this case now, we can now substitute our values. And we have 2 times 20 over 7. Oh, okay, our pi is 3.142 in this case, times 6,400 cos beta, which is the latitude we are measuring. So that will give us what you are having here. If you simplify that, we calculated that will give us 41,906.24 kilometers. Then to 100 kilometers, that will give us 41,900 kilometers to 100 kilometers as the length of that parallel of latitude 46 degrees now. So we are trying to measure the length of it. How wide is it, or the length of that is circumference. Now that's what they want us to measure in this case. Then for question B part of it, now we have to find the distance between K and Q. Distance between K and Q. So let's do that in the next slide. So we have to find the distance between K and Q, and that means we need to find that along that great circle or small circle, along the small circle, which is this latitude 46 degrees north. So we need to you need to find the angular distance first for between K and Q. So which I believe you should be able to do that because they are both in the difference between them is the longitude, which is in the same hemisphere. That means we are going to subtract this angle from this angle. That should give us a 77, I think. Did I say 77? That should be 27, I think. So, but if you use the diagram, so if you draw the line, so this should be this is 103 and this is 130. That means this line will be the origin now. So origin to 103 to 130. So that means this will be K, this is Q. So from the origin to point Q, that means the angle there is okay, you need to find the angular distance between K and Q, which is theta. Then from the origin to point Q, the angle there is 103, and from the origin to point K, the angle there is 130. So to find the theta, that will be 130 minus 103, and that gives us 27 degrees. Therefore, to find the distance between K and Q to the nearest 100 kilometers, that means you need to find that along small circle, which is that parallel of latitude 46 degrees north. So that should be theta over 360 times 2 pi r cos beta. If you substitute that, that gives us 27 over 360 times 2 times 3.142, which is the theta. Sorry, this is pi rather, times 6,400 cos beta, which is the latitude that they are both on, which is 46. Simplify that with your calculator, that gives us 2,095.31 kilometers. Then nearest 100 kilometers, that should give us 2,100 kilometers. Then the last question, they got to find the distance between Q and P. Distance between Q and P to the nearest 10 kilometers. Let's do that in the next slide. So distance between Q and P from here to here, that should be along that small circle as well, which is that parallel latitude. So, but we need to get the angular distance between them also, which should be the longitude of what they have in difference is the longitude. Longitude of Q is 103 and longitude of P is 23. They are in different hemispheres. That means I'm going to add it together. That gives us 103 plus 23. That gives us 126. But let's see from the diagram. If I draw the diagram of this as well, so that means between Q and P, this line will be the origin, and this will be Q. This will be P. Then the angular distance between them will be from here to here. So from the origin to Q rather, the angle there is the longitude, which is 103, and from the origin to point P, the angle there is 23 degrees, which is the longitude also. So the whole angle there, which is the angular distance between Q and P, is addition of the two angles. That gives 126 degrees. So if you have to find the distance between Q and P now, that will be along that parallel latitude for 6 degrees north, and that should be along the small circle as well. If you substitute your answer into this, you have this. Press the calculator, that will give us 9,778.12 kilometers to the nearest 10 kilometers. That should give us 9,780 kilometers as the solution to that question. So that's a full wire pass question also that we have been able to solve together, which I believe you understand. Let's see more question also in this. An airplane flies from a town P to Q. It later flies to third town this. Calculate the distance between P and Q along the parallel of latitude. Distance between Q and T along the line of longitude. The average speed at which the airplane fly from P to Q, from P to T via Q. If the journey takes 12 hours, quite a significant figure. How is this? Radius is this. So this is also a wire pass question also that we are solving. So we have been given geographical location of the 3 points. So this is a direct question. It's not like an indirect question like we have seen before. All right. So let's draw a circle to represent the Earth's surface. Then between P and Q, they are on the same latitude, 40 degrees north, which is a small circle. So if I draw that latitude 40 degrees north, then P is on 38 degrees east of longitude. So if I draw that, so I will label that to be 38 degrees east. So that means this point will be point P. Then town Q also is on the same latitude of 40 degrees north. Its own longitude is 22 degrees west. So I'm going to draw another angle here on the west of longitude. So we have another angle there that gives us 22 degrees west. So then this point will be point Q in this case. Then what they have in common, they are on the same latitude, which is a small circle. So I'm going to draw the radius from the center of the circle here, not the center of the head, but the center of this small circle to this point here. Then what do you have also? Then point T is the third town is town T is on the 28 degrees south of latitude, 22 degrees west of longitude. So what can we say? We can see that there's a relation between town P, T, and Q. They're on the same longitude, but different for latitude. So that means town T is on the 28 degrees south of latitude. So we draw the line. We will draw the latitude for town T, which is 28 degrees south, but it's on the same longitude as Q. So the same longitude as Q. So that means we have a point T here. So that means we'll be able to find the distance between Q and T, as you are asked to find it in question C. Yes. So which should go to be measured along this line that join them together, which is that longitude. And we know that longitude is a great circle. So I'm going to draw the radius from the center of the Earth here to the point T, Q, and to point T like this. So this is how the diagram will go. Then let's start to find what they also find one after the other. You have to find the distance. The first one, you have to find the distance between P and Q, which is here, the distance between P and Q here along the small circle, which is the parallel of latitude for 40 degrees north. So before we do that, we need to get the angular distance between them, which should be 38 plus 22. That gives us 60 degrees. But let's see that in the diagram. We draw the diagram between Q and P. That means I should be having Q here, I should be having P here. So this line at the middle will be the origin of the angle. So from the origin to point Q, the angle there is 22 degrees west. And from the origin to the point P also, the angle there is 38 degrees east. So if I am to find the angular distance, which is the theta, so theta will be 22 plus 38, that gives us 60 degrees. So we have to find the distance between point P and Q. So that will be along the small circle. So that should give us PQ equals to theta over 360 times 2 pi cos beta. Our theta is 60 over 360 times 2 times pi is 3.142 times 6,400 kilometer cos. Beta is the parallel latitude that they are both on, which is the 40 degrees. So if you simplify that with your calculator, that gives us a 5,134.74 kilometers, which you have to take to 3 significant, and that should give us 5,130 kilometers to 3 significant figures. So I want you to note down the distance of PQ because you're going to use it to find average speed. So note it down somewhere. Note the distance between distance between P and Q. So let's find the next question, which is the distance between Q and T. Distance between Q and T along that longitude, because that's what joined them together, longitude. So we have to find the distance between Q and T along the longitude, which is the gray circle. So we need to find the angular distance between them also. So let's draw the diagram also and see what we have. That means my Q will be here, my T will be here also. That means the line at the middle will be the origin of the angle. So from the origin to point Q, the angle there is that latitude they are both on, which is the 40, and that latitude that Q is on, which is the 40 degrees. Then from the origin also to the point T, the angle there is 28 degrees, which is the latitude here. So the total angular distance will be the total angle between them. That will give us 68 degrees. So you're going to find the distance between Q and T, which is that along the gray circle. That will give us theta over 2 times 2 pi r. If you substitute your values, you will have this. So if you approximate to 3 significant, that gives us 7,600 also. So I want you to note the distance between P and Q also. Did I say P and Q? This is wrong. It's not P and Q, it is QT rather. Don't know why I write P and Q again. So P, we have already gotten the distance between Q and T, Q and P. So it is QT. So please change this to QT, not PQ. This is a typographical error. So it is QT, not QP. Please change that. And note the value that we got here. So the last question, we have to find the average speed at which the aeroplane will fly from P to T via Q if the journey takes 12 hours, correct to 3 significant figure. So we know that total distance the aeroplane cover from point P to Q is what we got in the first slide, and from Q to T as well is another what we got again. So and to find the speed of the aeroplane, we need to know the total distance covered from P to Q via T. So that will be addition of the distance it cover in A here plus the distance it cover to in question B here. That give what this what you're having here. That's what we have done so far. If you add them together, that will give us 12,731 kilometer.4 kilometers. Then we should know that average speed we are finding speed is total distance over total time taken. So average speed of the airplane will be total distance, which is what you're having here, over total time taken, which is 12. If you simplify that, we'll be having this divided by 12. Then if you simplify that, give us a 10,060.95 kilometer per hour to 3 significant figures. That will give us 10,060 kilometer per hour. So and that's the solution to that wire pass question, which I believe you understand what we have done here also. So that will be all for this video, and I want to believe that you understand, you learn 1 or 2 things from this video. But if you want to evaluate yourself, you can evaluate yourself with these 2 questions, and you can send the result to me so I can help you to confirm that you are right or wrong. So that will be all for this video, and I want to believe that we have been able to help you one way or the other to understand the dynamics of latitude and longitude as a topic, which has been challenging majority of the teachers and the students. And I believe you will learn 1 or 2 things from this video. So, and I believe you have been able to help you and learn 1 or 2 things from this video. But before we go, please, if you like to subscribe to our channel, please click the subscribe button right away, right now, so that you will help us improve this video and the channel also. And please, we are begging you, for Christ's sake, share this video in all your social media platform and in all your groups that you belong to on the social media. Share this video so that there are a lot of people there who are desperately in need of this resource material. You can help us reach out to them by sharing this video. And don't forget to like and comment in the comment section of this video, and we'll see you in the next video. Thank you and God bless you. Bye.